Here's problem 1 from the Chapter 4 closure packet. Solve the system of equations at the right. So we have these two equations right here. Now we have 3 choices to solve a system of equations. One is equal values method, next is substitution, and the third we learned was elimination. So since this says y equals, one of the equations is solved already for one of the variables, I'm going to use substitution and replace all of this 3x plus 2 where the y is in the second equation, because this is the same thing as y. Y equals all this stuff, so I should be able to replace it right here, and it means the same amount. So over here, I'm going to start with the big equation. I'm going to replace the stuff in the big equation. So 6x minus 2 times this quantity, 3x plus 2. And then that still equals 8. We're still using the big equation and just basically putting the small equation inside the big equation. Equals 8. Okay, from here I'm going to use the distributive property. This is it says minus 2 or negative 2. I'm going to multiply that to both things inside here. So copy this 6x. Negative 2 times 3x is negative 6x. Negative 2 times positive 2 is negative 4 equals 8. Then I'm going to combine my like terms. 6x minus 6x makes nothing. Nothing is left over. So I have negative 4 equals 8. And that's not true. Negative 4 does not equal 8. So that means our answer is going to be no solution. There's no number I could plug in that makes the one equation equal the other equation, or the one side equal the other side. There's no point that would work. Okay? So part A, describe what happened when you try to solve the system. Well, I got no solution. Okay, graph the system of equations. So now I need to graph both of these lines. The first one is already solved for us in the y equals mx plus b format. So I'm just going to write here my slope, or m, is the number with attached to the x, so that's a 3, or 3 over 1. Okay, and my starting value is the number by itself, and that's just a 2. So I'm going to graph that one. So starting value is up at positive 2, and my slope is up 3, 2, 3, and to the right 1. Up 2, 3, to the right 1. And I can also go backwards from each point and go do the opposite of both things. So down 3 and left 1. See how that continues the same line. 1, 2, 3, left 1. Okay, so then I'm going to connect these points. You should use a ruler. Do not have one with me. So that's the first line. Now we need to graph the second equation. Okay, this is not in the correct format, so I need to solve this for y. So I'm going to rearrange it. So I need a minus 6x on both sides. I need to get rid of the things that are not attached to the y first. So this goes away here. Minus 2y equals 8 minus 6x. Make sure you carry down this symbol. That's what a lot of people forget. And then I need to divide by negative 2. Everything divided by negative 2. Okay, you don't have to write it like that, but that's how I like to. So now these negative 2's go away, so I have y equals, if I do each part separately, 8 divided by negative 2, I get negative 4. And then negative 6 divided by negative 2 gives me a positive 3, with an x attached to it. So this is my new equation. It's a new format for this same equation right here. Okay, so we solved it for y, we rearranged it. So I'm just going to also write down next to this, my slope for this one would be 3 over 1, because it's whatever is attached to x. And my starting value is negative 4. So I'm going to graph that line also. So start down here at negative 4, that's the y-intercept. I'm going to go up 3 and over 1. Up 3 over 1. Yeah, 1, 2, 3, 1, 1, 2, 3, over 1. All right, so there's my second line. And we see, okay, graph the equations. We did that, check. How does the graph of the system explain what happened with the equation? So when I solved it, I got no solution. How does the graph show this? If there was a solution, it would be when the lines intersect each other, where they cross. These lines never cross because they're parallel. You know, they're parallel because their slopes are the same. They both have the same slope of 3 over 1 and 3 over 1. So we have both lines have slope of 3, so they are parallel. and will never intersect. Oops. That's an L at the end of that word. And never intersect. Okay? So since they never intersect, they never have any points in common. No points in common. So there is no solution. Because the solution would mean where they intersect. And since they have no points where that happens, that's why there's no solution. Okay? So this might happen similarly if I graph them and I get the same line. There's going to be something interesting that happens then. So normally when I graph two lines, they cross, but it also could happen where they never cross like this. They're parallel, and so the answer would be no solution when you solve it algebraically.